Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later from our college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they are also conducting different exams to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Because he's teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came from for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also, there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone. It was really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother, I showed it to my friends. I felt really good about it. So I would really suggest XLR. I would recommend it to all my friends to take courses from here, as they focus on the children, focus on the students, and they focus on what's necessary, that is the students' doubts gets cleared and everything else. So today I came down to the XLR office to collect my certificate. So I got to know about what other courses XLR is offering. It included data analysis, data analyst, social media marketing, and full stack Java, and many more courses which were interesting, and they gave us an insight of how everything happens, and they take you through the course from the starting of the course to the end, and what next, that is placements as well. How you should be going into the interviews and how you should be approaching to companies, your resume building, and there were so many things which XLR is going to help you in, and they are ready to give you all the knowledge required even if you are a beginner. So I really felt good about this visit, and I would really recommend XLR to everyone who's listening to this, and also to all my friends, that I had a very good experience with XLR, and I would suggest you to experience the same. Thank you.
Hello everyone, my name is Satish and I am from Swami Vivekananda Institute of Technology. I am here to share my experience about XLR program. I took part in the XLR program that was conducted in the last month about the mobile app development using Flutter. What I liked the most about this session was the trainer started from the scratch. That means even the beginner who don't know about the basics of the program, even they can learn the most from this program. It gave me hands-on experience by developing a project which was the final outcome. Thank you XLR for giving me this opportunity, and I would also recommend all my friends to take part in the XLR programs. Thank you.
Uh, Good evening, everyone. Please confirm me if my voice is audible for you. Please confirm in the chat box. Yeah. Thank you. Thank you so much for your reply. And we'll start our sessions. So in the last session, we discussed about what are the different types of controllers and the processors are available, and how we are going to control. I mean, do that. Why we need that particular controller, and what is different controllers are available in the market, and we see all. We learned all of them. So in again, I introduced a basic controller, which is nothing but a Arduino. So that is a basic for developing for an embedded system product. Okay, so that we are learning. So in the last session, we discussed about the hardware part of this particular Arduino, and in today's session, we'll discuss about some software part, and what is this software and how to write a code in this particular software. We'll try to discuss that in today's session, and also we'll do some programming part also. Okay, fine. So coming back to our sessions, in this for to do a coding part to this particular Arduino, we have a software called Arduino IDE, which is nothing but integrated development environment. Okay, so this is a software which we use to write the code, and also we use to upload the code, etc., etc. That we use this particular software. Okay, which is nothing but Arduino IDE. Okay, so this particular software which works on all the platforms like Windows, Mac, and Linux. Okay, by simply what we use to, we need to connect our Arduino to the system in of any operating system, so using a USB cable, and with a single click we can upload the code to the particular Arduino. Okay, so and we have an IDE is there, we call it as an, which is nothing but we have a text editor which is works like an notepad, and a compiler will be there which works on that. Okay, and this compiler is used to convert code into that machine understandable language. Okay, and unlike text editor of an IDE is a software tool which we generally use it for a lot of other functionalities also, right? And generally in this particular Arduino IDE, we use embedded C++. Okay, so what is an embedded C++? For in a short, let me explain you. So C is nothing but it is a procedure-oriented programming, which is nothing but we call that as a fundamental language. Am I right? So I hope everyone knows about this C. So it is a fundamental language. Coming to the C++, it is a C with class, or what we call it as an object-oriented. Am I right? So here, this particular embedded C++ is nothing but it is a programming oriented to an hardware. If we are writing any code for any hardware devices, then we call that as an embedded C++ or embedded C. Okay, so here, like what I mean to say is, if you are writing any code for any hardware, say suppose if you write a code for this or normal like addition of two numbers. Okay, like we used to take into a comma b and c, like a is equal to scanf, b is equal to scanf, and c is equal to a plus b. Like that we'll write a code, but we are not writing this for any hardware. Okay, just we are executing that particular program. But if you are writing that, if you want to implement the same thing for any hardware, if there is a keypad, if you want to use that particular keypad for getting an input, just like for a calculator, so at that particular point of time, so we need that embedded C++. Okay. So that embedded C++ is nothing but if we are writing a programming or which is further than hardware, then we call that as an embedded C++ or C. Okay. And this Arduino is basically based on this particular embedded C++. And this Arduino is a cross compiler. Okay. What is meant by a compiler and a cross compiler? Can anyone tell me? You can reply in the chat box. What is meant by a compiler and a cross compiler? The same code can run in different ways. So are you saying for the compiler or cross compiler? Okay. What is meant by cross compiler? Cross compiler. Okay. Right. Any other answers, guys? Okay. let me explain you without wasting much time. So here, generally, there will be a compiler will be there, which is nothing but which converts from high level language to low level or low level to high level. So it is based on a compiler. It converts from one format to another format. Okay, like the program execution and execution done on the same machine. But coming to the cross compiler, the program will be created on one particular machine, and the what we say program is executed in some other machine. Okay, we are writing code in one particular platform or one particular place, and the execution of that particular program is done in another machine. Then we call that as a cross compiler. In Arduino, we are writing the code in our laptop, and the program, that same code is executed in Arduino. So that's why we call it as a cross compiler. So 80% of all these embedded things, everything is works only on this particular cross compiler only. Okay, so it converts, this compiler will converts that, and Arduino compiler will converts that from hex file, and that particular hex file will be uploaded into the Arduino board. Okay, so all the computer CPUs, microcontrollers or microcontroller only understand this hexadecimal language. Okay, right. So, and this Arduino IDE is open source. I told you we can use this code and we can write. It supports C and C++. Basically, we use for this C++ only most of the cases. And the programming here, we call that as a sketching. Okay, in generally, we call that as a sketching. So we need to connect to our laptop to upload the code, and the sketch, which is nothing but a program in Arduino language. Okay, so that will be saved with an extension of .ino. Okay, and there are some other licenses are there. Right now, it is not needed for us. Okay, and let us see some programming languages based on that particular embedded things. What are the different types of programming languages are available? So let's see that. Just a second. Okay, right, fine. So in generally, in our day-to-day life, we all know, right? These embedded systems, we use these particular embedded systems. Almost 95% of all the products which we are using are all embedded systems. So these particular embedded systems will must have a specific set of features. So developers program them using certain programming languages. So uh, you have may wonder like video game systems or a software or a hardware. It combines both the things. Like we have an hardware things are there, we have a hardware. So or we all need to understand that software part is nothing but it is a collection of instructions which is used to operate that particular hardware, which is nothing but the physical devices, mechanical parts of that system. So both need to accomplish. So programming languages for embedded systems are very important. Okay, so right, let us see some programming languages on this. So first of all, let us see what are these programming languages. Right. So embedded programming language is a language that developers use in the embedded systems. Okay, in general. So these languages offer low level access to the device hardware. So developers use several common programming language for embedded systems. So like C, C++, Python. Okay, even some cases they use Java. So it depends upon that particular module or that what we say that not vendor or manufacturer what they use, we can use that particular programming language. Okay, so here are a few languages which we used in what we say in our embedded systems, right? So here before the C language was introduced, so basically this is a prominent languages which you can see in this particular slide. But before the C language was introduced, so the developer used some basic programming languages, which is nothing but the assembly level language to develop these embedded applications. So these assembly languages programming are not portable in nature. Okay, so we there have some restrictions for the developer. They were not able to fully engage in that particular process for the development of these embedded applications. So with the improvements in these particular embedded programming languages, many new languages came into the picture. So that is the introduction of the C, Pascal, and some other things are there. Like, so there are new, but they have some problems are also there. So developers mainly they work on that particular assembly level languages. So after some advancements in that particular programming languages, so the C languages will give that particular some flexibility for developing that applications. So what I mean to say is before the C, there is a language called assembly level language. Through that particular language, it is I mean the developers can't will be fully engaged in that programming, developing that particular. After the introduction of the C and after some advancements in the C, the developers task got easy. Okay, so there are many advantages whenever they are using this C programming languages. They can easily to work. Simply they are converted. They can use that, and there are some applications are there which they can complex applications are there which they can what we say make it in much easier. The coding part will be much easier. So they have some processes are there, etc. There where they can easily program it, etc. etc. So embedded C language is one of the most widely used for this embedded programming for microcontrollers. And after that, they will have C++, Python is also there, Java is there. Micro Python is nothing but just like an embedded C or embedded C++. We won't call embedded Python, we call it as a micro Python. Okay. Right. So this is how a generally a embedded C programming will do. So this is the most popular language in the software field for developing any electronic gadgets. Okay. So each processor which are used in these particular electronic systems will be associated with some embedded software. So these embedded C programming which plays a key role in performing such functions in the processors. So in a day-to-day life, what are the mobile phone, washing machine, digital camera? All these are using this mostly use this particular embedded C. So we need to convert that C programming into some extra programming, and then we need to dump into the particular microcontroller. So this is the general processes of this particular embedded C. Okay, so that is the introduction. Just a second. Sorry, guys, 1 second. Right. So coming, let us see about this particular embedded C program. That is a basic program which we discussed. Right. So this C program is nothing but that is extension of C languages. So in C compilers are all operating OS dependent. So embedded is an OS dependent. So embedded C is a hardware dependent, which is not the case with C. Okay. So because embedded C is nothing but it is the programming for the hardware. So it is an hardware dependent. Okay, it is not easy to modify or debug embedded C like C languages. So that is the key things. And we have another widely used language which is nothing but embedded C++ due to the high stability. So C++ is used in many embedded systems, including our IoT technology also. So it is easily portable, most reliable since it is an object oriented language. So the disadvantage here is its lack of garbage collector. The concept of pointers is challenging here to understand, and it needs a large amount of storage memory. And one more programming is there like Java. So Java is also used in some applications, by GUI applications, but most of the cases Java is not widely used when compared with C or C++, but in some cases we use this particular Java. And Python is also there. Most of the cases, all the controllers, okay, so will be used mostly C++ languages. Only in some cases we use like processors. Mostly we use Python programming for the processors like Raspberry Pi, BeagleBone, etc., etc. Okay, generally, if we strictly talked, we called about MicroPython, okay, which was used for running the microcontrollers and embedded. In the most of the cases, 70 to 80% we use embedded C and C++. Okay, so these are the popular language embedded programming languages. You can see over here. This is things out of which Python is most widely used, and after that we have C and C++. This is the differences of this particular um, programming languages. Okay, and so just a second. Right. So why most of the people ask the question like if you have a doubt that why Python is more preferable for an embedded system. So there are some key features are there. As one thing is this all Python is an open source and freely usable, even for the commercial projects. So for that we have some key features are the debugging and equipment control. So these are the few things because the C and the C++, all the functionalities of that will be what we say will have that in the Python programming. Am I right? So for that purpose we use this particular Python in most of the cases. Okay, so benefits of using Python for embedded systems like C, C++ have a good run efficiency, but these languages are difficult and take up your time during the coding part. So as you know, I hope in the starting lecture in the first session, I asked you to go through the basics of C and C++ and Python. So Python having more advantages when compared with C and C++. So in say suppose in C or C++, if we write 10 lines in Python, we can write only 2 to 3 lines. So that is during the coding will be less when compared with C and C++. Okay, and also there are some other advantages. We can directly integrate with some online parts, etc., etc. For Python it is easy. Okay, and this is a sample code of writing in a C or C++ language, and this is for we are writing the same code in the Python. If you can see the differences between both, they are all the green color ones are the comment section, but they have some other black color things. So like this is a C programming and this is a Python programming. So you can see the number of lines is very limited when compared with that. Okay, right. So let us come back to our Arduino. So I just want to give you an overview of the programming languages which are there in that in our embedded systems. So this are the let us discuss about the Arduino software, how to install this. We'll discuss that. Right. So if you have your laptops, you can work along with me. If not, no, don't worry. So right now we are not working on this particular software. So you can install it for our further sessions. Okay. So you need to go to an official site. Okay, let me go to the official, like I'll explain you to in a practical way. Just a second. So let me open the browser. Right. So you need to go to Arduino.cc, the official site of this particular Arduino. Okay. Then you need to go to the IDE part. So click on this particular IDE in the products, and you can download the versions over here. So first you go to Arduino.cce and then go to the products. There are different products are there over here. So you need to use for an offline mode, you can use Arduino IDE. So there are some other things are there. I'll explain little later. So click on that Arduino IDE. Okay, and you will be redirected to this particular software page. So there are two softwares are available over here. So one is Arduino IDE 1.8.19. So this is the old version. Okay, and we have one more software is there, which is nothing but Arduino IDE 2.3.4. So this both versions having same functionality, but UI is little bit different. Okay, so depending upon your operating system, you can download accordingly. So most of the cases we have Windows, so you need to click on this particular Windows, and this particular software will be downloaded. Okay, the same stuff. Okay, two versions are there. So while you are downloading, it will ask you, as this is an open source, if you want to contribute, you can contribute, or else you can click just on just to download, and after that it will ask you some agreements to accept. So accept that particular agreement, and just click on next, like installation options and folders. So they will it will ask. So click on that, and if you want to save this in some other folder, you can browse it, and then click on that particular. And also it will ask you to accept some security installations. Okay, so you need to ask that, you need to install all those. And after successfully installing, you can see an icon like this. This is a old version icon, but new version will be having in a square one. Okay, so I recommend you to use the latest version. Okay, because there are some benefits are there when compared with the older version. So new version is good because the libraries will be auto updated. If the Arduino people introduced any what we say new features or a new updates, that new version will auto update that particular thing whenever it connected to internet. So the platform, the IDE will be auto updated, but it's not in the case for older version. We need to do it manually. So I prefer everyone to use a new version. It is good for you. Okay, and also after that it will ask you for giving it ask for that access to the Java platform. Just click on that. Okay, and after that you can see this type of ID. This is the new version. Okay, the names are different, sorry for that. So 2.3.4 is updated. The screen, the image which I kept is little bit older, so nothing but just I updated it. Okay, you can see this is a newer version, and this is the older version. Okay, so just UI is little bit different, but both works similarly. It's up to you to use any version. Okay, but I prefer the new version because of some advancements in for that older version. Okay, right, let me go through this. What are the things are they available over here? Let me open that for you for an understanding rather than the software. So after successful installation, uh, you can see this type of icon on your screen. Okay, this is the icon. So double click on it. Double click on this, and your software will be opened over here. So just a couple of minutes. Right, you can see here, it is asking, so there is a new update. My version is 2.3.4. If you carefully observe, now it is asking an update is available. You want to download it. Right, this is the what we say, uh, advantages of using this particular new version. So I'm just clicking download. It won't take much time, just because only a few updates will be there from the older version to new version. Okay, so just a couple of minutes. Okay, so you can see at the bottom also it is asking there are some what we say updates are available for your libraries for the boards. Okay, so you can install that. But in the older version, you don't have these particular features. Okay, so you need to check for any updates. If updates are there, we need to install it manually. Okay, so just a second. It's a new update. Previously, before a couple of weeks back, I used the same version, but now it is updated. No need to worry. Just like our mobile phone, how we get updates in the similar fashion, we'll get this update. So right, close and install. So I'm just giving some access. Just a minute, guys. Okay, right. Let me explain this. Okay, I have a older version of PPTs. Just a second. Okay, fine, no issues. Okay, right. So before explaining about the software, let me uh, okay, right, explain you this older version. The same versions will have that same features will be available. So here we have the sketch, which is nothing but the name. We can see the file name and the version over here. And we have a menu bar and we have a toolbar is available. And this is a text editor for writing the code. And below that, you can see the status, uploading status will be displayed here. And if you have any errors in that particular code, which we wrote, that code will be the errors will be displayed over here. Any some configuration things can also be displayed in this particular white screen. And at the bottom you have a configurant board and the serial board, which board you are using, at what port you connected, that will be displayed over here. Okay, and let's come back to the toolbar. This is what the important thing is after writing the code. So if you want to verify the code, so for any errors, everything, so you need, there is an option is available like tick mark. Okay, this tick mark is used to verify that particular code. Okay, and after successful verification, we have, beside that we have one more button is available, which is nothing but upload button, which is having that arrow mark. So after verifying, the code will be verified. It's not only it will check the syntax errors and not logical errors. So if we don't have any syntax errors, then we need to go back, we need to upload the code to the boot. So we need to press this particular upload button, and the code which we wrote will be converted and then uploaded, sent to that particular Arduino board. Okay, and if you want to open, you can open a new file. You can use this particular new, and if you want to open any existing sketches or programs, you can use this open and also to save. And we have one more option is available like serial monitor. I'll explain it to you in a whenever we are working practically, right? And just a second, let me check whether that is updated. All right, thanks. So it is completed. So let me open this. Okay, so this is an IDE, new version IDE. Right. So you can see over here. So this is just like a name of that my particular file. And you can see this is a version 2.3.4. This is a menu bar, which is available file. So in this particular file, you have general options like save the program examples, open recent, new, sketch, etc., etc. And we have some edit options and sketch tools and help are there available. And here, this is a white screen where we need to write our code. Okay. And then we need to dump it. And beside that, you have some options or is available. Like this is a sketchbook. Okay. And if you want to open a new sketch, click on that new sketch and a new sketch will be opened over here. Okay. And you have one more option is available, boards manager. So this particular Arduino IDE will have that particular capacity of what we say include of other boards, like only this IDE can support some other boards also, like node MC boards, particle boards, etc., etc. You can install that. Okay, there is a search option is there, like say suppose particle. Okay, there is particle board is not there. Okay, fine. Like say suppose ESP8266. Okay, there is a board. We can install like that. Okay. And below that we have a library managers. So libraries, we need to install that particular libraries. Okay. So even though in the Python, whenever you want to install any Python, you use a command, right? Pip install that particular library. So here we need to install it. So you need to search for that particular library. So like a Telegram bot. So there are some Telegram bot, library is there. Just we need to install that particular libraries. Okay. If that particular libraries is not there in this particular list, you need to install it manually. Okay. So there are some debug, some search options. These are the few other things are there. In the older version, you don't have this particular sidebar. Okay. You need to access all through this particular menu bar only. Okay. And this is the verify button. You need to click on this particular tick mark to verify the code, and arrow mark to upload the code. And if for any debugging message, you need to select. So one thing you need to remember here is after opening here, we need to do two steps. Okay, that is mandatory for everything. So I'll explain that, and we'll go to the programming part. Okay. So here we need to select one thing is say suppose I told you, right? So this particular Arduino have different flavors are there. Okay. So before writing any code, we need to select to which board we are writing the code for. I told you, right? Not all Arduino flavors are having the same microcontroller. So it will differs, right? So first of all, we need to select to which board. Even though if they have the same microcontroller, are some alterations are there. The pins are GPIO pins are in some boards they have more, in some boards there are less. Like that will be there. So first of all, we need to select the board. I'll just show you what are the boards are available. So in the tools bar, there are boards are there, Arduino boards. If you are installing it for the first time, you won't see these additional boards. I installed these additional boards manually. That's why you can see this particular ESP328266 boards. But for the people who are installing for the first time, you don't see these particular boards. You have only Arduino boards is available. These are the Arduino boards are available. Okay. So you need to select to which board you are writing the code for. Say suppose if I am writing the code for Arduino Uno, you need to select that particular Arduino Uno. So that is the first step. Okay. So I'll tell you two process to do this particular thing. First of all, I'm doing it from the menu bar. So go to tools and select the board here, Arduino AVR boards and Arduino Uno. Okay. And after that, you need to select the port. Right now, this is in disable position. Why? Because I didn't connected any Arduino board to my laptop, to my system. That's why this is in disabled position. Whenever you connected any port or any board to this particular your system, this particular port option will be enabled. You need to select that particular port. Port is nothing but the communication port. Okay, which means that USB port. So through which USB port, through which communication port, you are transferring the data to that particular Arduino. That port we need to select over here. That is the two steps which we need to do, right? So the thing is, first of all, we need to select the board. Okay. So initially you have only Arduino boards. You need to select that. And after that, you need to select the port. So to which port this Arduino board is connected. Okay. So you need to select for some situations, you will see only one port like COM3, COM4. COM is nothing but the communication port. okay, which is nothing but the USB port. To which board it is connected, that we can see over here. And if you see that there are a couple of ports are there, if you don't know to which communication port your Arduino got connected, then you need to go and search in that particular device manager. So in that particular device manager, you can see to which port your Arduino is connected. So that will be available in that particular device manager under the port session. There is an option is available like port section option. So in that particular port option, you can see to which COM port your Arduino is connected. So that is about this particular Arduino. So this is the basic stuff which we need to know. Okay. So is it clear, guys? Do you have any queries? So this is what you need to do. So here, this is the first method, like go to tools, select the board, and the second select the port. That is the first method. And the second method is like, so you can see there is a white box is available. Directly you can select over here. So click on that select board and here. So you need to select the board over here. What boards are there, like your Arduino select that Arduino Uno and select. Or else if you are using Arduino Mega, you need to select Arduino Mega and you need to select that particular board. If you are using Arduino Nano, just type Arduino Nano and you need to select that particular Arduino. And after that, if you are connecting the ports here, this port, no ports discount because I didn't connected any port. So once the port, if you connect your port to your laptop, the ports, this particular screen will be enabled. You need to select that particular port. Okay. So for new version, this option is available, but older version, you don't have this particular option. Okay. So this is about the overview of this particular what we say new version 2.3.4. And next, let us discuss about how to write coding part. Okay, right, fine. So to this particular Arduino board, you can connect all types of sensors, input devices, etc. And also you can connect some output devices like motor, LCD screen, LED, 7 segment display, buzzer, etc. etc. These you can connect to this Arduino board. The basic, all basic components or in some advanced intermediate moderate sensors also can be connected to this. Okay, so let us see how to write a code into this particular Arduino. Okay, so there are multiple ways are there to write code to this particular IDE. Any queries, guys? If you have any queries, you can ask me in the chat box. So industry graded sensors can't be connect to this particular Arduino. As I told you in the previous session. So this is a basic component or basic controller. So industry graded for sensors are nothing but the operate. You need to think about the operating voltage. So the operating voltage for this Arduino is 5 volts, but industry graded the sensors will work with 12 volts or 24 volts. You can give external voltage, but this Arduino doesn't support that. Okay, what operating voltage is any um what we say 5 volts. Okay, like say suppose industry graded sensors like we can see suppose temperature sensor is in industry, so the operating voltage of that particular sensor is 12 volts. So you can connect that particular sensor to Arduino because the maximum voltage for Arduino is 5 volts. Okay, so if you are take the output of that particular 10 sensor and if you give to Arduino, the Arduino will get damaged because the output range of this particular sensor, temperature sensor, is varies from 0 to 12 volts. So that we need to convert that into 5 volts and we need to send to Arduino. That is a big hectic thing. Again, the values won't be in a proper action. Okay, that's why we won't use that industry graded sensors to integrate with this Arduino. Okay, and yes, this Arduino IDE is free. You can use this. In our day-to-day life, we can use, guys, in Arduino. Say, suppose you can connect a Bluetooth to this particular Arduino. So you can connect your fan, your light, your everything to that. Okay, for that we need some extra component like relay, like board. So using that particular Bluetooth, from your mobile, if you send a signal like one, so the tube light will on. If you send a two, the fan will on. For these smaller applications, okay, we can use Arduino. Okay, say suppose for a basic mini projects. So if you want to use any wheeled robot, you can use that particular boards. For Arduino boards can be used. Okay, right. For coming back to this mm, ways of writing the code, there are two ways are there. Okay. So, I mean, generally multiple ways are there in which I'll explain you two ways. One is there are some predefined syntaxes are there which is provided by this particular Arduino company. Okay, they developed this particular software and also this coding part. Using that particular what we say programming syntaxes, we can directly write the code in this particular Arduino, or else we can write code directly to that particular microcontroller at Mega 328. That is a microcontroller, right? We can directly connect to the right programming to that particular control. Okay, so I'll just show you how to the second one, which is how we can write a code directly to that Arduino. So here, this is a just a program for blinking an LED. Okay, sorry, LED blinking. Okay, so here I'll just explain you. So first of all, as you all know, we need to include a library over here. So as this particular microcontrollers which we are using are from AVR, AVR microcontrollers. So we need to include that particular library. AVR slash IO. IO is nothing but input output. So this library will provides that input output registers which are specified that particular AVR. Okay, and then we have one more library is there. We need to include that which is an header file util slash delay. So this particular library is used for this particular delay statement. Okay, for that we need to include it, and after that we need to define that to which pin we connected this particular LED. Okay, as I told you, right, there are um, GPIO pins are there, general purpose input output pins. Okay, to which pin we connected this particular LED, that we need to mention. So here I mentioned like PB 0. So nothing but port B and pin 0. Okay, port B and pin 0. So if you remember that particular IC diagram, there are some ports are available. So okay, let me show you where it is. Right, right. So if you carefully observe here, you have a port B, port C, port D, pin. These are the ports. So we are writing the code directly to this particular IC, right? So we are selecting that PB not. Okay, so this is the PB not, this pin. So I need to access this particular pin. So that's why I'm writing is here like a PB0. So this defines uh, to which pin I connected my LED. Okay, this is a symbolic representation of that. Okay, and then int main void. Okay, the main function is where the execution starts, and here this is the configuration of that particular PB node. Okay, so DDRB is nothing but data direction register for that particular port B. Okay, what is this data direction is where so what component you connected, it is an input component or it is an output component. Okay, so that will be defined by this DDRB, and one is less than bitwise operator LED pin, so shifts one to the left for that. Okay, and also while there is some DDRB will be there. So here in this particular one is less than LED underscore pin will set that this particular PB naught will be acting as an output component. Okay, so and here this pin one can't be changed, right? So it will be fixed, and inside that we have a while loop, and because we are blinking this LED, so we need to write while of 1, which is nothing but while of 2. So forever the loop will runs. So the LED will continuously blink. Okay. So here I am writing to turn my LED on, I will need to make this particular high. So here port B. So nothing but port B output register is used for that particular state of that particular pins. So here to make this particular what we say pin, which is nothing but PB not too high, we need to use this particular bitwise operator. Whenever we use this, my LED will be on. Okay. And after that, I'm giving a delay of milliseconds, and I'm using a negation symbol, so which is nothing but will be acting as low, so my LED will set into 0. Okay, so my LED voltage will get 0, so my LED will be off. So this is the general programming to write a code to directly to that assembly level, sorry, to the microcontroller. Understood, guys? So it looks little bit complicated, but this company, Arduino company, gave some good syntaxes to work with, which is very easy to write the coding part. Okay, so I'll just write an example. I'll just explain you about this. Okay, so there are the syntax whenever you open IDE. Okay, so let me open a new sketch. So whenever you open a new sketch, new Arduino, you can see there are two functions are available. One is void setup and one is another while loop. So this is by default. Whenever you open this particular what we say board, you'll see this particular two options. Okay, so this what is meant by this particular setup and loop, let us discuss that. Okay, and what is the setup is nothing but, so whenever you write some statements, okay, I close the program. Okay, right, fine, let me open one program, right? So this is a sample program. Okay, I'll just explain you. So here all this we generally include some header files over here and some other configuration things, global declarations, etc., etc. And this is a void setup. If you carefully observe this particular void setup, you can see a statement over here like put your setup code here to run once. So these particular statements, if you want to execute any statements and if you want to run any statements only for one time, and that statements we need to write over here. And if any statements, if you want to execute for infinite number of times, here the term is there like loop. Loop is nothing but it's just like an infinite loop, right? Like that, what we say, these particular statements will execute for infinite number of times, because while loop is nothing but just like a uh, sorry, while loop is just like a while loop. Okay, so that we can execute it in this particular what we say programming part, in this particular code. Okay, so that is what here I mentioned, like so setup is nothing but the first and one time execution, so which is used to configure the Arduino. Okay, and loop is nothing but it is an infinite loop. If you want to execute any statements for multiple number of times, then you need to write this particular while that's those statements in this particular while loop. Okay, and these are the two functions which are available whenever you open these particular things. Right. For again, one more uh, thing, like one more statement is there, which is nothing but pin mode. So this pin mode is nothing but, say suppose if you connected a component to your Arduino board, okay, you need to mention, right? So what is that particular component and what is that component is an input component or it is an output component, that we need to mention, right? So this pin mode statement will execute that particular thing. With pin mode statement help you to find out whether that is an input or an output component to the company. Okay, got it. So it is an intimated Arduino about that particular peripheral, like what is it is an output or it is an input component or it is an output component, that will be intimated. And this is a syntax for that particular pin mode, as this is a C languages. It is case sensitive. You need to follow the syntaxes. So pin mode, MA should be capital, pin is small. So pin mode, pin comma status. So pin is nothing but to which pin you connected that particular component. And status is nothing but is this an input component or an output component, that you need to mention, right? So let us see some examples like how to evaluate this particular pin mode. Say suppose an analog peripheral or analog component is connected at pin A2, and and it is an output component, say suppose, and you need to write this particular syntax like pin mode A2 comma out. So this is an analog component, right? So we need to mention A comma. As I told you, Arduino have both analog and a digital. So you need to mention for analog, you need to mention A. For digital, no need to mention D like that. If you simply write the number, then it is fine. So this is a digital peripheral. If you are connected to so pin 3 and it is an output component, that is the syntax how you need. Right. And also there are these are some other examples. So pin mode for analog if it is an input. So A1 comma input. Likewise pin mode 0 comma input. Okay, got it. And so where we need to write this particular statement. Okay, where we need to write either setup or loop. Can anyone tell me in the chat box? Yes, we need to write in the setup because this is if we intimate the compiler, then it is enough for one time, right? So we need to write this particular pin mode in setup. Okay, so pin mode should be written in setup as it is a configurable bit. Okay, and next let's see how to access this particular pins. Okay, say suppose there are GPIO pins are there which are analog and digital. So both will act as an input component as a input, and they'll accept the data, will send the data. So input and output. So there are some terms are there for nothing but read is used for input and write is used for output. Okay. So input nothing but we are taking that. Which is nothing but we are reading the data from that particular component. So that's why we call it as a read. So if you are sending some data to that particular component, output component, output peripheral, then we call that as an write. So writing the data and reading the data. Reading the data means getting the data from that component. Writing means sending the data or sending the signal to that particular component. Okay. I hope you understood. So let us discuss about the another syntax, which is nothing but digital write. Okay. So this is a digital. This syntax we generally used only for digital pins. Generally, we use for digital pins. So digital and status is nothing but the output. Okay, write is nothing but output. Right, output. So number of arguments is 2. There is no return value. So this is the syntax for that particular digital. Right. So digital write W should be capital and D should be small and pin comma data. So pin to which pin you connected that particular component. First of all, you need to mention the pin mode and then you need to write this particular pin. Okay. So pin and the data. So as this is a digital component, you have only binary data 0 and 1. 0 is nothing but low and high. 1 is nothing but high. So whenever if you want to pass 0, then you need to write a low. And if you want to pass a high voltage 5 volts, then you need to write high over here. Okay. So similarly, analog write. Okay. So analog write of pin comma data. Pin is to which pin your component got connected. That pin you need to mention and data. So this is an analog. So you need to give you some values. Okay, like 0 to some values. It depends upon. I'll explain that little later. So try to remember that data is not 0 and 1. It there we need to pass some voltages over here. Okay. And both are digital read and digital write and analog write. That is the syntax. And now we'll discuss about this digital read. So digital read is nothing but reading the data. So here from which pin you are reading the data, that we need to use this syntax, the digital read and pin from which pin you are writing. So as this is a digital, you possible outputs is either 0 or 1. And here digital analog write, analog read. So here the data will be read. Okay. So here the value of this particular analog read, the output of this particular, it completely depends upon ADC, which is nothing but analog to digital converter. So if you remember the structure diagram, at that particular point we discussed like the sensor, and in between the processor and the sensor we have a converter, analog to digital converter. So at that time we discussed like the output of that particular sensor is in analog. So that analog values will be converted into digital format. Why? Because the controller understands only the digital things. So this ADC will help to convert that analog values into digital values. So the value which we get an output from this particular analog read it completely depends upon that particular ADC. Okay. So there is no restriction that you won't get only 0 or 1 only with 100 or like that. No. So it completely depends upon that particular ADC. Got it? And here there is analog write is there. So the data, this data completely depends upon, let's just give me a second. Um, right. So here this particular data, the value will be depends upon the bit architecture. So it completely depends upon the bit architecture. So this Arduino is like 8-bit architecture. Am I right? If you remember, this is an 8-bit architecture. So nothing but the data here will be calculated with a thing called 2 to the power of n. So you may have a doubt like what is the value which we need to pass at this particular data right, analog right. So what value we need to pass for a digital thing, you can pass only high and low. For what about this data? It all depends upon this 2 to the power of n. So 2 to the power of n is nothing but, okay, which is equal to the power of 8. Okay, so which is nothing but 256. Okay, so the range of this particular data is nothing but, it range is nothing but 0 to 255. Okay, that is the range. So you need to give a value in between 0 to 55. So 0 is nothing but 0 volts and 255 is nothing but 5 volts. Okay. So if you want to pass any value like 2.5, say if you get like 228, so you are giving a value of like 2.5 only, 2.5 volts. So that is what this analog write is about. Whenever we are doing the practical, we'll get to know all this. Okay. So clear till here, guys? Any queries in this particular statements? If you have any, please let me know. So if not, we'll try to shift to the coding. Okay, someone asked, sir, and this. Yeah, MicroPython also we can write for PB0. We can write it, guys. That's not a big deal. Okay. So at that time we won't write PB0. We'll write some names. Okay, right? So fine. I hope you don't have any queries. If you have any queries, you can ask me in the chat box, guys. Right. So here, right now you don't have any Arduino board with you, and people doesn't have if you don't know, if you didn't know about this Arduino, before, then it is first for you, and I won't recommend you to buy this and do the practice, connect the sensor like that. First of all, we need to know how to connect this and what are the peripherals are there, how to code this, etc., etc. So for that, for a beginner point of view to know all this stuff, we have a simulator. So this simulator is used to know and to explore how to write the coding part and how to connect some peripherals to that Arduino. What happens if we misconnect it? Everything we can see in this particular simulation. So if you directly use this particular board, I mean directly boards hardware, maybe there is some chances are there. Um, uh, what we say, you'll get some mistakes in that. Your component will get spoiled or Arduino board will get spoiled. Just for an practical, like what we say, um, understanding to know how it connected, I'm using a simulator. Okay. So someone is asking a query download. So your laptop won't hang, guys. So this is a very small software. No issues. Okay. So here for that, I'm using a simulator which is nothing but Tinkercad. Okay, this is a general basic simulator, but you can do all your stuff for Arduino. Only this is for Arduino. So you can search, just search Tinkercad in your Google, and you can find the first one, which is from Autodesk. Okay, so just click on that, and this Tinkercad is open. This is from Autodesk. So generally this Tinkercad is used, it is free for everyone. Okay, so you can use 75 million people are using this particular Tinkercad, where you can design some 3D things, where you can explore some circuits. If you don't know any coding part also, you can use some code blocks will be available. Just use that particular code and you can develop code blocks, and you can develop some code also. Okay, that can also be done in this particular simulator. So first of all, this is a free version, so no need to uh, bother. Just click on login and use your personal accounts, and with that you can sign up for free. I already have an account, so I'm just opening it. Okay, so this is what looks like. So I already used it, so that's why there are some circuits are there. But for the first time, if you are using, you don't find any what we say circuits. It will be new like this. Create your first 3D. There will be a option will be displayed at the point of Tinkercad. As I told you, so there are, we can use 3D design, we can develop design circuits, we can develop code blocks, etc., etc. And so here we are using the circuits for our programming part. So here click on this particular create and go to circuits. Okay, so a new circuit will be opened for you. Okay, so this is a new circuit. Okay, whenever you open, you will find this type of stuff. Okay, so let me explain you how what is this things. So on the top, you can see a dazzling, fluffist, and some name, unique name is there. So whenever you open a new circuit, a unique name will be displayed on it, some random name. So you can change it by just a click and then change it. Okay. And then here onto your left side, you can see, so your right side, you can see circuit view. This is a circuit view, and after that you can find this particular schematic view. So the schematic image can be displayed over here, and the components list can be also displayed. Okay, first of all let me connect that, and then you can explore that. So first of all, here in the to your right side, you can see all the components are, these are the basic components, because in this particular column, like basic or components, only basic components got selected. So if you click on all, so all the components will be displayed which are available in this particular Tinkercad. Okay, so all the components are displayed. So let us do fun basic program for an understanding how to do. So here my thing is, let me connect a small LED and then turn it on. Okay, for that, what components do we need? So we need an Arduino, So just type that Arduino in the search bar and just drag and drop that particular search bar in this particular white field. Okay. So this is just like very simple. Okay. So just drag and drop and this particular in this particular space, project space. Okay. And this is Arduino, guys. That's what we are learning, right? Right. Fine. So here and let me drag. Okay, here there is a inbuilt LED is there on this particular Arduino. So this is an inbuilt LED. L is nothing but the LED. So let us configure that particular LED. So here there are some sample code is also available over here. Whenever I drag and drop, a general normal code will be generated. So if you want to see, just click on this particular code. Okay, and here I told you, right, there are three modes are available. One is blocks. So these are the blocks. You can drag and drop something, you can create some code over here. Okay, that can be done, but we'll write the code. Okay, for that click on this blocks and select the text. Okay, and it is asking are you sure to want to that, and click on that particular things. Okay, okay, right, there is an inbuilt code is there. Okay, let me delete that. Okay, so okay, right. Let me remove this. Why it is code? Right. So let me write. So pin mode. Okay. Okay. Right. No need all this stuff. Let me integrate an LED and teach you. So here, Arduino is there. So we need an LED, right? So take an LED. Just type that. You'll get this particular LED over here. Okay, so as you know, I hope you know about this particular LED. LED having a two terminals. One is a cathode and anode. Cathode is nothing but the negative. Anode is nothing but the positive. So how we need to connect? Can anyone suggest me how to connect this LED to that Arduino? Lines, yes. How to connect Arduino to which pin? Cathode to which pin? Can anyone suggest it? Okay, nothing. Negative ground, VCC and ground. Okay, right, right. I got many answers. Thank you for your it. Thing is, anode. So we need to connect it to ground. Sorry, cathode to ground and anode to any one of these particular digital pins. You can connect to any pin from 0 to 13. You can connect to any pin. Let me connect it to the 9th pin. Okay. So this is what how you can connect. Okay, right. So here in there we have an options like you can change the wiring. So there is a wire color is there, so you can collect it, you can change it to any color. Okay, that option is also available in this particular thing. So just for a differentiation. Okay, so let me write the code. Okay, so let me write it. So first of all, so we need to tell the compiler to what component it is, what is as an input and an output. So for that we have a syntax, right? Like pin mode. We can use that particular pin mode. So pin mode, and this is an LED, right? So which I connected to 9th pin. So syntax for pin mode is pin mode, pin comma status. Am I right? So pin, which is nothing but 9, and status is nothing but this is an output component, just so you need to write output. So if you note the code, you can write in the chat box and you can send it, guys. Right. And also we have an inbuilt LED, right? This is an, let me configure that also. Like for that LED pin. So you can write like LED underscore built in. And that is an output, right? So it is an output. We need to write that. Okay, we'll do the both LEDs. Okay, and now what statement I need to use? Can someone, if you I want to turn this particular LED on, what statement I need to use? We discussed, right, few statements. Can someone suggest me what statements we need to use and where to use? In the setup or in the loop? My task is only to turn this particular LED on. So you can pin in the chat box. Yep, someone is saying setup. Someone is saying loop. Loop. Okay. So let us see both the cases. Okay. So let me write in the setup. So how to write? So we have a statement. Which statement we need to write? Digital write or digital read? As this is a digital component, I will be connected to digital pins. So which statement we need to use? A little bit fast. So digital write. Very good, right? So digital write. And what is the syntax for digital write? So digital write of pin comma status. So here pin comma, what is the status? I want to turn it on, right? So I'll turn this particular 9 comma high. Okay, right. And also there is one more LED there, right? Built-in LED. So I want to configure that. So digital write of LED underscore built in, and I want to make it high. Okay, so I wrote these statements in setup. Okay, let me execute it. So start simulation. So after writing the code, you need to click on start simulation. And here you can see my LED got damaged. Why, guys? Can anyone tell me why? Why? In the chat box. Right. So let me tell you why it got burned. That's why we need to work in simulator to know some things. Okay. So if you place your cursor on this, you're seeing that current through the IO pins on DT9 is 53.5 milliamps, which is exceeding the maximum, absolute maximum of 40 milliamps. So this may permanently damage the Arduino. Okay, so what we need to do is, it is nothing but, in a short, I'm saying that the current of this particular is passing more. So that's why it may damage it. And there is a one more option is also available. The usage of this LED might reduce. So to avoid this particular situation, what we need to do is, we need to take a resistor. I hope you know what is meant by a resistor and why we need a resistor. So I need to take a resistor, okay, and I need to connect it. So where I need to connect? Across this anode. So connect one end to of a resistor to anode and another end to 9 volts. Okay, and now you need to start the simulation, and you can see my LED is on and there is no error. And you can also see over here, this LED is also on. This is nothing but the built-in LED. Okay, so both LEDs is on. Okay, got it? Got it? Any queries till now? If you have any queries, you can ask me in the chat box. Okay, so let us see. Let us see what happens if we write the code in this loop. Okay, I'm just writing the same two lines in this particular loop, and let's see what happens. And you can see, even though my LED is on, okay, then what is the difference of this? What is the difference? So both are the same, guys. Both are the same. There is no difference because we are doing a single operation. We are not using couple of operations. So here, what is this? In both the statements, we wrote like to turn this LED on. That is only one operation. Either you write in the setup or if you write in the loop also, we don't find any difference. So let us see the difference because see, right? So first of all, next task is like I want to blink this LED. Okay, so let me write these statements in this particular loop first. Okay, setup first. Okay, so let me blinking in nothing but turning on and off. Okay, so right now let me remove this particular built-in. You can use it. So for instance, I'm deleting this particular built-in. Okay, right. So here, let me write those statements. So how to blink an LED? Can anyone suggest how to blink an LED? How to blink an LED? Can anyone suggest in the chat box? Okay, right. So blinking an LED is nothing but turning on and off. To turn it on and off, how to run the code? Nothing but there is a start simulation is there. So if you click on this start simulation, the code will run. Okay, if you have any errors, the errors will be displayed. If not, the program will start. Okay. Right. Set pin mode to low. No, guys, not pin mode. Okay. So, right, what we have to do is we need to write one more statement, which is nothing but digital write of 9 comma low. Okay. So one is this statement will execute like my LED will on, and another statement is there like LED is off. Okay. The LED will be on and off. Is it right? If I write these statements, my LED will blink. Can anyone suggest? Yes or no? Maybe. Oh, good answer. No, 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 yes. Okay, let's see. What is it? It's a simulator, right? So let us see. So start the simulation. My LED is, you can see again. Let me see. And here carefully observe. Oh, nothing is happening. So even we can't see whether it is on and off. Why? Because this here, my I wrote a statement like high, okay, and low. Okay. That these statements are executed in a fraction of seconds that even we can't notice that the LED is on and off. Okay. So let us make it a little bit understandable to our naked eyes. For that, let me use a delay statement. So this delay statement is there, which will pause that particular previous statement for that much period of time, some amount of time. So here I use it like delay of 1000, nothing but for 1000 milliseconds. Okay, so that will be in pause position. Okay, so okay, is it enough to write one more delay? No, we need to include one more. Okay, no need. That is enough. Okay, so let me start the simulation. You can see LED is on and off. But here it is not blinking. Okay, you can see again. Let me restart it. Start LED is on and off because these statements are executed only for one time. Okay, because we wrote that statements in setup. Am I right? So these statements are executed only for one time. Okay. So what I need to do if you want to blink this, so I need to write those statements in. So let me stop the simulation. Write that statements in, okay, in the void loop. So what happens if we write in the void loop? So let us see. Okay. And here, let me see. Start the simulation. What happened, guys? It is in on state. I can't see the blinking. Where I went wrong? Can someone suggest? Is the code right? the code right? My statements are right? Like high and my statement is low, but why my LED is not blinking? Okay, right. Someone is suggested. We need to give one more delay statement over here after low. Why? Why means, so this statement is executed and after it delay for 1 second, 1000 is nothing but 1000 milliseconds, guys. 1000 is milliseconds, which is equal to 1 second. Okay. So after 1 second, this low statement is executed, but it is in while loop, right? Again, after low, again this high statement is executing. So without a no time. Okay. So that's why we can see only the LED is in high state, but there is low statement is also executed, but we can't see that. Okay, so that's why I'm including one more statement like delay. So just now start the statement and now you can see my LED is blinking. Now you can see it is blinking. Got it? LED is blinking. Okay, right? So this is how you need to do. So for a beginner point of view, okay, I suggest this simulator because you can explore more. If you directly connect the same stuff in a real scenario, previously we see, right, some damage, component damage that might happen. So for that, if you get some experience of how to connect this, how to write the code, to explore the code, so this simulator will be a best option. So that's why I'm introducing this. Okay, right? Very good, guys. Someone are also doing along with me. Very good, guys. Thank you. Right? Fine. And then stop the simulator and you can save this particular code. And how to save this? So just click on this particular name and just save, right, blink LED. Okay, and this particular page will be saved. So no need to use any controllers or that. This all changes will be saved. And let's explore some options over here. And here I told you, right, this is a component view. And if you click on this schematic, you can see this schematic diagram. So what is the resistor? Where you connected that particular resistor? This is a D9, nothing but ninth pin we connected, right? So that is connected, and this is an LED, red LED, and the pins are grounded. You can see this is a schematic diagram. Okay, and you can download it. You can use it in your reports. And there's a components list. These are the component list which we used. Arduino component, red LED, 1 kilo ohm resistor we use. This is a component use. We can also download this particular. It depends upon your requirement. If you want, you can uh, write things. Okay. So just follow the syntax, guys. W should be small capitals and remaining all should be in small letters. And high should be in caps and uppercase. Okay. Got it. And after saving the date, you can use different things. You can see toggle nodes. You can write some nodes tool. So you can drag if you want to know. You can write a note over here. Light blinking. Okay, like you can write, these are the different options are there. You can mention here for your understanding. It is all depends upon you. Copy option is there, paste option, delete option. You can see, click on that and you can delete it. You can undo and redo also. Okay, all these things are available over here. Okay, just to send to, you can send it the same thing to some other friends also. These are the few other things. Got it? Okay. And so after, if you want to save the, it is auto saved. If you want to open a new file, you need to go to the dashboard. Okay, how to go to the dashboard? So click on this particular Tinkercad and then you'll be redirecting to your dashboard. So once you go to the dashboard, again you can use this option like create and circuit, and a new circuit will be created. Okay, right? You can share, guys. You can share it. Okay, someone is asking how to blink a double LED. What is meant by double LED? two LEDs. You can connect two LEDs, guys. That's not a big deal. Okay, let me go back and explore in the two LEDs. Yes, you can do. Okay, okay. Let me go back. This is the LED, right, which we declared. So if you want to do some changes, you need to click on this tinker this. Tinker this means you can edit this. Okay. So here, this is a red color, right? If you click on this red color, you have some options over here. So red, there are green, LED, orange. You can change that orange thing. So if you want to connect one more LED, drag one more LED. Okay. And let me change the color. Let me change to orange. Okay. And same thing, you need to convert cathode to the ground. So click on this particular ground. So you can use the same pin. Okay, let me use the black color. Okay. So, okay, anyway, it's fine. So cathode to ground. So ground, you can, sorry guys, black, white is up. Sorry, it will connect. Right, it is connected. You can use the same ground, or else at the bottom also you have two ground pins. Okay, you can use these grounds also. Okay, or else you can use breadboard. There is a breadboard option is available. You can use, if you know breadboard, you can use this breadboard. Okay, right now I'm not introducing that. And again, you need to have a resistor and connect anode to that particular resistor and connect to any one of the digital pins. So I connected to D4. Okay, you can change the color for an understanding. And come back to the code. Again, you need to initialize pin mode. So pin mode, like which pin we connected, 4 comma and output. Okay. Similarly here, write digital write of 4 comma high. Okay. And some delay, and we need to write here like a digital write of 9 comma low. All right. So same thing. Just start the simulation and you can see both LEDs are on and off. Why it is not blinking? Just a second. 4 4. It is on state only. Why? Sorry, it is not 9. Oh, sorry. This is 4. 4 comma low. Am I right? One is the ninth LED, another one is 4 LED. So you can see blinking. Got it? Yeah, thanks. You can use RGB also, guys. RGB also. RGB is nothing but multiple color. Okay, right? So that RGB is also available over here, like RGB. Right. So here the RGB is nothing but multiple colors will be there. Like one cathode, red, blue, and green. You need to connect red to different digital pins. One cathode and if all three are anodes, you need to connect to all of it. There are some other RC, RGB like PRC. You can use any type of signal that you can try on your own. Okay. All right. So let me go back. And let me, I already opened a new sketch, right? That sketch is already in open. Okay, like this, summarizing. This is one more thing. So we'll discuss one more thing, how to read, to explore the digital read. Let us work on that particular digital read. So what components that my task over here is I need to use a button to read. Based on that particular button, so my LED will be on. If I press the button, my LED will be on. If I release that button, my LED should off. Okay, that is our task for today. Okay. Right, for that, what are the components do we need? Can anyone suggest in the chat box? So I'm coming from the scratch, guys, so that you can know it. So generally we need Arduino board and one LED, and we need a resistor for that particular LED, and also we have a push button. Push button is available beside that particular LED. This is LED. There are two types of buttons are there, like switch are there. This is a switch and this is a button. So button is nothing but it is just act like a calling bell. If we press that particular calling bell, we can hear the ring, right? So just like that, if we press this particular button, my LED should on. If we release this button, my LED should off. That is my task over here. Okay, so let me connect that. So cathode, so let me use wiring. So black color for ground, I connected to the ground, and use a red color for connecting the anode. So let me connect it to 12th pin, any digital pin, guys. It's not mandatory. You can connect from 0 to 13, anything. Okay, coming to this particular button connection. So here you can see 1A, 2A, 1B, and 2B. Okay, so just look at these connections. So 2A should be connected to 5 volts. So I connecting it to 5 volts. Okay, and 1A should be grounded. So for that I'm taking a resistor. So this is a connection for connecting this push button. So take a black and connect 1A to the resistor and another end to the ground pin. Okay, and we need to take output of this particular button from 1B and connect it to any one of the digital pin. Let me connect it to D7. Okay, got it, guys? So this is the connection for connecting this button. Similarly, for the hardware, real hardware also, you need to connect in the same fashion. Okay, got it? Any queries in this? Okay, right. And then how to write the code. If you have no queries, then we'll shift to the coding part. So click on the code over here. Click on the code and you need to select the text and click on continue. Okay. So whenever you see there is an inbuilt code will be there. We don't want that particular inbuilt code, and so that's why I'm trying to remove it. So that is an inbuilt code is available. Only that code all the time. Right. So here I'm using little bit different coding part over here. Try to observe. So if you know the C language, it is easy for you. So as define. So I'm defining that particular 12th pin for as LED, and also as define button for the 7th pin. Okay, instead of using 12 and 7, I use LED and button for not getting confused. Okay, so next I need to use pin mode. I need to write this pin mode in the setup. Okay, so this particular pin mode, so which is used for that particular connections. Am I right? So intimate the Arduino board. So Arduino board, first of all, LED comma. So we need to make it. This is an output component. So we need to write output. Okay, and then if it is like we need to mention the button one also, right? So button, and this button is an input component, right? So I need to write input. Okay, so right after that, where I need to write the logic in the setup or in the loop. So if we write in the setup, we can execute it only for the for one time. Okay. So if we write it in the loop, then we can execute for multiple number of times. So let me write in the loop. Okay. So here, let me take one more integer. So like to store the value. So integer. So like button value. Okay. I'm taking this variable button value. So here button value is equal to, so here I am using the statement called digital read. I want to know the status of that particular button. So I am using that particular digital read. Got it, guys? Clear? All right. So here after that, so if based on that particular button status, I need to turn this particular LED on. So I'm using if else loop over here, statement over here. The if button value is double equal to 0. Okay, what I need to do? I need to turn my LED on, right? So digital write off. Okay, nothing but if my button is pressed, okay, my LED should on. So digital write off LED comma high. Okay, else digital write off LED comma low. Okay, and flower brackets closed. Okay, understood. Okay, let me run it and check whether it works perfect or not. Okay. Okay, sorry. LED should be 1 over here. So the button value should be 1. Okay, now start it. And you can see I didn't press the button LED, so the LED when press the button, so LED is off. So I am pressing the button and you can see my LED is on. Okay, so now LED is off. I'm pressing the button, LED is on. And if I release this, LED is off. Okay, right? Understood? Very simple program. Uh, right. So let me modify this. This looks like a beginner level of writing the code. So let me modify this. So let me use this particular statement directly at this particular position. Okay, I don't want these particular values. Okay, I'm removing this also. Right, and also if we are using only one statement, again no need of writing this what we say, I mean including these particular flower brackets. So now it is very simple, just a 4-line code. Okay, so just start and press it, you can see LED is on, and if you release it, off. Okay, and also we can do multiple things like this. If you press it, my LED should blink. That can also be done. For that, for multiple statements, I need to use flower brackets. So give a delay of 1000 and write a digital write of LED comma low, and give a delay of 1000 and again. So here nothing but whenever I press this particular button, my LED will blink. Okay, so start the simulation. Okay, and no errors, and just press, you can see my LED is blinking. Okay, when I press that particular button, you can see my LED is blinking, and release it. You can reduce the delay also. You can make it like a half second, like a 500, nothing but 500 milliseconds if you want to make it fast. So after initializing again, so you can see start button and you can see my LED is blinking fast. Like that, you can experiment on this things. Got it, guys? Any queries in this thing? Explain the button connection. Okay, fine. Nothing here. Let me connect it one more time. Let me delete this. Okay. So this is the button. We have 1A, 2A. Totally, this is a 4-pin button. Okay, 1A, 2A, 2B, and 1B. Okay. So first of all, what we need to do is connect 2A to the 5 volts. So 2A, click on that and connect it to 5 volts. We have a power pin, so connect to that particular 5 volts. Okay. And for 1A, we need to connect it to the ground but we need to use a resistor. So 1A, so I'm taking a black one, so connect it one end and another end should be connected to ground. Okay, right? This is a positive connection, and we need to connect 1B to any one of the digital pin. Got it? That's it. And start the simulation. We connected it to 4 hours, 7 hours. Right, no need. We can change it to 4. Okay, right. Start the simulation and then go on. Bas. That's it. Okay, you can see the schematic diagram. You can see this is a schematic diagram. So power connection, this is a button. This is a button diagram. And these are the components which we used. Okay. Okay, the schematic, you can download it and you can paste it in your reports. Okay. So that's it. Any other queries in here, guys? Okay. So we have couple of more statements are also there, like analog write and analog read. Okay. So let me go for analog write. Okay. We'll see analog read in the next session. We'll go for analog write. Okay. After that, we'll wind up. Okay. So again, do the same process, change the name, and you can go for a new sketch if you want to save this particular codes. Or okay, I recommend you to save it. I already have saved it, right? So that's what I'm doing in the same part. Okay, right. So my question is to explain that my question for you is, can I connect this particular LED to analog pins? Can I connect LED to analog pins? Yes. No. Yes, can someone reply? Someone already replied. Can I connect LED to analog pins? Yes, we can connect, guys. Okay. Right here is what is happening here. When if you want to go in deep, so here we have a potential difference over here. Am I right? So nothing but ground is nothing but 0 volts, and from 12 we are getting 5 volts. But this particular LED is operating voltage of this particular LED is 3.5, 3 volts only. That's why we are connecting a resistor to reduce that particular voltage. Okay. So if you have a 5 volts LED, you can directly connect to it. Okay. So here, what I'm doing is I connect this particular um, sorry, I need to relate to the wires. Okay, wires, sorry, connect this LED to analog pins, okay, using the same resistor. Okay, so cathode is nothing but ground, right? So let me connect it to the ground. Okay, right. So here the thing is like whenever we connected, there the positive will have a 5 volts and the negative will have a 0. There is a potential difference of 5 volts, and we connected a resistor for that operating voltage is 3.3 LED, so that pass will be there. But whenever we are connecting to analog, we can vary. Sometimes you can see the brightness like the intensity of the LED, the brightness of the LED will sometimes is like decreasing and increasing, increasing and decreasing. That type of thing is there, right? So that can be possible when we connect this particular LED to analog ones. Okay, right. So that's why we are using. So here in analog, if you uh like okay, okay, forget about it. Like so, let me connect this resistor. So let me connect to one end to this and another end to any one of that analog pin. Okay, any analog pin. Okay, so let me write the code. So let me modify this for time being. Okay, no, let me remove this. not to get confused. All right. All right. First of all, let me define this. So hash define LED. I connected it to A4. Okay. Then we need to write in the pin mode, like sorry, setup pin mode. So LED, which is an output component. Okay. So now come back to this loop. So what is the syntax for this? Can anyone tell me in the chat box what is the syntax? Which syntax we need to use? Which statement we need to use? So analog write. Am I right? So analog analog write. Okay. What is the syntax for this? Let me write the syntax for an understanding. Pin comma data. Okay. So it is a syntax. So let me comment this. Okay. Right. And let me write the one more time. So analog write. Pin is nothing but say suppose what is this pin? If LED, right? Right. And what is the data? Can someone tell me what is the data here? What data I need to pass? What data to want to glow this particular LED? Brightness, yes. What is the data? How much value is the data? Is nothing but value. 1 to 1000. Okay. Are you sure 1 to 1000? I told you just now, right? Previously, I told you. If you remember. So the data is completely depends upon the bit architecture. Right, 1 to 255, 2 to the power of n, 2 to the power of 8, which is nothing, 8-bit architecture, right? 2 to the power of 8, 256, nothing but 0 to 255. Okay, 0 is nothing but minimum and 255 is the maximum. Am I right? So let me write that same stuff, 255 and giving some delay of 1000. And again, let me write like analog write of LED comma 0. Okay, so delay of 1000. Okay, let me run this program. You can see on and off. Okay, right, on and off. That is fine. Like through analog pins also we can control this particular LED. Then what is the difference of using this analog, right? We can connect to digital, right? Then why we are using analog, right? Then what is the use of that? What is advantage of? So there will be some advantage, right? Right. So here we can, whenever if you want to increase the brightness of this particular LED, like slow to maximum or maximum to low, so this analog write will be used. So let me write that particular statements for your understanding. For I'm using a first statement like int I equal to 0, I is less than or equal to 255 and I plus plus. I'm using a for loop, and here analog of, instead of 255 I'm using I, and say suppose 100 delay. Let me use delete this. Right. So now you can check. So here what happens? Can anyone tell me what code I wrote over here? Can someone tell me? Increase intensity of the light. Yes, very good. Intensity of the light will be increased. That is the range. So that is the advantage of using this particular what we say LED connecting it to the analog value. So let's start the simulation, and you can see the brightness will be slowly increasing. Okay, because we gave some delay, right? So the brightness will slowly increase. Okay, right. Okay, you can see my brightness of that particular LED is increasing. Previous it is like you need to iterate, right? So that iteration will be happen. Okay, right. So that's it for today, guys. If you have any queries, you can ask me in the chat box. Okay, so that's it for today. In the next class, we'll try to see some other stuff. Okay, how to integrate a sensor, what is analog read, how we can read the data from an using analog means using that particular sentence analog read, how to integrate some other sensors, etc., etc. Right. I plus nothing but I'm incrementing that particular I value for one time. So please go through the basics, guys. And I hope you know it or not. So Saturday, Sundays we don't have classes, and Monday is holiday. And again we'll meet on Tuesday. Okay, any other queries, guys? So if not, we'll try to wind up this today's session. And thank you, guys. Thank you for attending for today's sessions. I hope you enjoyed the session. Okay, and happy weekend. And see you on Tuesday for the next
Yeah.
class.
Yeah. Thank you, sir. Thank you.